Um, since there's just one person watching right now, I'm just gonna go over this, and as you have questions, just ask in the chat. Um, really, this chapter is just setting up proportions and solving them. That's pretty much everything there is. So as I go, just ask questions, and I'll get to them when I look up. Okay. Since more and more people are coming in, are there any questions over number one or two? All right. Again, the two basic concepts here that in order for two polygons to be similar, uh, corresponding angles must be congruent and corresponding sides must be proportional. So number one, we had to do a little bit of maneuvering to find these angles. These are two sets of parallel lines cut by a transversal. Okay, so they end up all being congruent. Then we have to set corresponding sides up as proportions. So 5 over 24 equals 7 over 21 equals 5 over 24 and another 7 over 21. Those things are not equal, so they are not similar. Did the same thing for number 2. All these angles are right angles, so they're all congruent. And the next thing we need to do is check if the sides are proportional. So 40 corresponds to 32, so 40 over 32 is equal to 30 corresponds to 24 is equal to 40 corresponds to 32 is equal to 30 corresponds to 24. And all of these fractions are equal, so they are similar. How much work do you need to show? I would like you to set this up. And then simplify. If it requires you to find angles, then find the angles. Ideally, you simplify all this. Yeah, I mean, about all of this. There's not a whole lot there. It's more writing than probably it looks like, but I would expect that. Okay, number 3 and 4. So this gives us that the polygons in each pair are similar. So we know that polygon 1 is congruent to polygon 2, which means it follows these two rules. Okay, so we're given that it follows this. So then we just need to find the missing side. All right, so really you only need 2 sides for this. So I'm going to set up 30, which corresponds to 25. That will be equal to our missing side over 35. And we have to find this missing side. So grab a calculator. We'll get there, Emmett. So if we multiply by 35 on both sides, we get 1050 divided by 25. And that is equal to 42. So then that's our answer. Okay, same thing for number 4. 35 corresponds to 28. And then our question mark corresponds to 24. Cross multiply. So this is equal to 840 divided by 28, which is equal to 30. Now you cannot get extra credit for having notifications on. Thank you, though. Even though it doesn't really do anything. I don't get paid for this. Anyway. Number 5, again, same thing. This 30 side corresponds to this 36. And then this question mark corresponds to 24. So if we multiply by 24 on both sides, we get 720 over 36, which is equal to 20. So 3, 4, 5, that's generally what we're doing. Number 6 and 7 is just throwing x's in there. So on number 6, 36 corresponds to 30. So we do 36 over 30. And then 48 corresponds to 3x over plus 13. So then 48 over 3x plus 13. Then we still do the same thing. So multiply both sides by 3x plus 3, 13. That cancels. Keep in mind this is in parentheses. Actually, I'm just going to cross multiply and divide this so I can save a little bit of space. So this entire thing is equal to 40. So 3x is equal to 27, so x is equal to 9. And then we do that again on the other side, on number 7. All right, so 16 corresponds to 12. Right, this 16 corresponds to this 12. And then 2x minus 6 corresponds to 9. So if we multiply this 9 out, we get 144 divided by 12 is equal to 2x minus 6. So 12 is equal to 2x minus 6. So 18 is equal to 2x. So 9 is equal to x. So again, 3, 4, 5, 6, 7, they're all similar. 6 and 7 are just a little bit harder because it throws in an x and a constant. But it's the same idea. Again, we're just setting up proportions and solving them. All right. 8 and 9, state if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. Show all work. Okay, number 8, we're given one angle. So that's going to be like kind of our anchor point. And then 2 sides on both that are both adjacent to angle B and J. All right, so that means if we flipped these triangles so they were matching, B would be where J is, C would be where K is, and D would be where L is. So 21 would correspond to 14, and 27 would correspond to 18. So in order to see if these two triangles are actually similar, we need to make sure that this proportion is equal. So 21 over 14, that is 3/2. And then 27 over 18 is also 3/2. These two things are equal. So then the two triangles are similar because we have one side that is proportional, an angle that is equal, and another side that is proportional. So these two things are similar because of SAS. And then it would be JKL would be similar to BCD. So just again, side angle side similarity requires that we have one angle that is congruent in each triangle. And then the two sides on either side of that angle must be proportional. Number 9, we kind of do the same thing. We have a common angle, which is S. So S is in common with this small triangle and then this bigger triangle. All right, so we have one angle, and we need that the two sides are also proportional. In terms of simplifying, like I would rather you do fractions. I'm not going to take off if you put 1.5. To me, fractions are a little bit easier. 21 and 14 both have 3 or 7 in common. If you take 7 out of 21, you get 3. If you take 7 out of 14, you get 2. That's how I do it. If you want to use your calculator for that, that's fine. I don't have a problem with that. But again, back to 9. So we have one angle, and then we need to check that this side corresponds to this entire side. And then this side corresponds to this entire side. So if we do that, 27 will correspond to 27 plus 18. And that should equal 33 over 33 plus 22. All right, so keep in mind that these longer sides are these smaller sides plus a little extra. That's why I'm writing it as 27 plus 18. All right, so then this equals 27 plus 18. It's 45. And then 33 and 22 is 55. And we need to see that these two numbers are equal. So if you do it TJ's way, this is 0.6. This is also 0.6. So those sides are proportional. So these two triangles are similar because of SAS. And STU would be similar to SKJ. Questions about 8 or 9? So you know it's SAS because we have one angle, which is this angle right here. So these two triangles both share this angle in common. All right, so this angle is congruent, this angle in the smaller triangle is congruent to this angle in the bigger triangle. All right, so that's our anchor angle. And because we don't have any other angles, right? So let me back up a little bit. We have three reasons to prove that two triangles are similar, right? We have AA, angle, angle, which says that if two angles in one triangle are congruent to two angles of another triangle, then the triangles are similar. Then we have SSS, side, 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 that says that if three sides of one triangle are proportional to three sides of another triangle, then the two triangles are similar. Then we have SAS, which says that one angle in one triangle is congruent to one angle in another. And then these two sides are proportional. So when that happens, well, what we did on this problem, this JS side is proportional to this SU side. And this SK side is proportional to this ST side. So because those two sides are proportional, or those four sides are proportional, and there's an angle between them that is congruent, that means we're dealing with SAS. $27 corresponds to so okay. I'm gonna redraw this. So you have you have big triangle. And then you have tiny triangle. All right, we know that angle S is congruent to itself. So we have this. All right, this SJ side, that's 27. This SU side is 27 plus JU. Right, so it's 18 plus 27. So it's SJ plus JU, which is 18 plus 27. This SK side, that's 33. And then all of S and T is 33 plus 22. Because SU is made up of SJ and then something else. ST is made up of SK and something else. All right, so on the blue triangle, there's a little bit more than what's on the red triangle. And again, we know it's SAS because we have this one anchor angle that's congruent in both. And then this is proportional to these two ratios, so 27 over 18 plus 27, that equals 33 plus 22 over 33. Because sides adjacent to this green angle are proportional. All right. So next, before I move on, are there questions about 8 or 9? Okay. Number 10, same direction. So see whether or not the two triangles are similar, and then if so, state why and what triangle it's similar to. All right. So the first thing we need to notice is that there are vertical angles right here, which means that they're congruent. So now that we have one angle, we can prove that this side corresponds to this side, and then this side corresponds to this side. So we need to see if those are proportional. All right, so if we do that, we have 24 over 104. That should equal 39 over 168. So 24 over 104, that's like 0.2307 something something something. And then 39 divided by 168. They're not quite equal, so this is... So these are not equal to one another. Therefore, they are not proportional. So I just say not proportional. And then number 10 is kind of the same thing as number 9. But in this case, it's actually given us 3 different sides. You can do this either using SAS or SSS. I'm going to use SSS just so people see it. But if you were to use SAS, we have this angle in common. So then you would just see if this side is proportional to this entire side, and this side is proportional to this entire side. So you can do that. I'm going to do SSS just so people see it. All right, so if we do that, 14 corresponds to 91. 18 corresponds to 117. And then 8 corresponds to 52. And we need to see if each of these are equal. And they are. So because all 3 sides of one triangle, i.e. this smaller triangle, are proportional to all 3 sides of the bigger triangle, then the triangles are congruent by SSS. And PQR is similar to triangle PBA. All right. Next, just finding the missing length. Again, this is all using the same concept. We're setting up a ratio and we're solving, or we're seeing if they're equal. All right. So number 12. There's 2 triangles. They're this smaller W2S, and then there's the bigger WVU. They both share a common angle. We're given that they are similar. So we know that their sides are proportional, right? So 42 corresponds to 56. That's this side corresponds to this side. And this side, this unknown side, will correspond to 56. Now, if you just look at this, you don't really have to do any math here because you know that if this bigger triangle is isosceles, right, both sides are 56, then this smaller triangle also must be isosceles. So this question mark has to equal 42. And then you're done. That's your answer. Now, if it wasn't isosceles, then you'd have to multiply out the 56 and simplify, but they're isosceles, so you don't have to do any more work. Number 13, it's kind of the same thing, except you are given an x. So you're trying to solve for x instead of just a missing side. All right. Again, concept is the same. And in this case, you are given 3 sides of each triangle. So I'm going to draw this again so people don't get confused. If this smaller triangle is red, this side is 2x minus 1. And then the blue triangle, so you really only need 2 sides for this because we're given that the pairs are similar. So our x is in GQ, which corresponds to 56. And that will equal, let's just take 36 over 96. And you could also pick 33 over 88, but it's really just up to you. And then we got to multiply out this 56. So we get 2x minus 1 is equal to 21. Add 1 to both sides, we get 22. Divide by 2, we get 11. So before we move on, are there any questions between anything from 1 to 13? All right. So the next couple, just simplifying radicals and then using the Pythagorean theorem. All right. Simplifying radicals. In order to do this, we want to try and take out as many perfect square factors as possible. So this is like one of the first things we did. But the general rule is that you can rewrite this as the product of two different radicals. And we want one of those factors to be a perfect square. So for example, square root of 90 we can rewrite as the square root of 9 times the square root of 10. 9 is a perfect square, so the square root of 9 is just equal to 3, and then this root 10 stays alone. So your answer is just 3 root 10. Okay, for 15, I'm going to write it kind of like this. And then we can rewrite this inside as the square root of 9 times the square root of 2. Again, the square root of 9 is just 3. And then we multiply 7 by 3 rad 2, so we just get 21 rad 2. And kind of the same thing for number 16. We can rewrite 8 rad 27 as rad 9 times rad 3. Rad 9 is just 3. So then 8 times 3 is 24, so it's 24 rad 3. No, they're not all going to have square root of 9. But we need to know kind of some basic perfect squares, right? So 5 times 5 is, well, okay, so 2 times 2 is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared, 49. We should be at least somewhat familiar with like up to 10. After that, like I know up to 13 pretty well. But those should be decently familiar. So if you do 6 times 3, yeah, all right, we can do that. So if instead we do this, right? Then so there's no perfect square here, but we know we can simplify. We can rewrite square root of 6 as the square root of 3 times the square root of 2, and then the square root of 3 comes back down. Because there are two square roots of 3, they kind of combine together to just be 3. So then this becomes 7 times 3 rad 3. It's 3 rad 2. Okay, and then 7 times 3 again is just 21. And then the rad 2 stays. So you can do both ways. If you do 6 times 3, though, you got to simplify that 6 just a little bit more. So questions about 14, 15, or 16? Yeah, basically. Yeah, so if you have two square roots, so say you have the square root of 5 times the square root of 5, that's just equal to 5. The square root of 8 times the square root of 8, it's just 8. So let's go to 17 and 18. Before I do that, Pythagorean Theorem. So for any right triangle, provided it is a right triangle, the two adjacent sides to the right angle are A and B, and the hypotenuse, the longest side, is C. If you have this, then A squared plus B squared is equal to C squared. Okay, that's what you need to know for 17 and 18. Okay, so for our number 17, 13, this is our C. We can call 11A, and X, that's our B. So if we set this up, we have 11 squared plus X squared is equal to 13 squared. Then we're just solving for X. Okay, so 11 squared is 121, and 13 squared is 169. If we subtract 121 from both sides, you get 48. And then in order to cancel out the square and just solve for X, we take the square root of both sides to get the square root of 48. Yes. Yeah, the proofs will be the same. All right, and then in order to really get this answer full credit, we got to simplify the square root of 48. So I know that we can rewrite the square root of 48 as the square root of 16 times the square root of 3. So then this is 4 rad 3. Number 18, again, 16 has to be our C. The two sides attached to the right angle, that's our A, and we'll call this B. So then we have 8 squared plus X squared is equal to 16 squared. So 64 plus X squared is equal to 256, I think. Yep. (256 minus 64), it's 192. Then we take the square root of that. I don't think that simplifies. Nope. All right. So that's not a perfect square. So we gotta, I'll split it in halves. So this is square root of 96 times the square root of 2. We can rewrite 90, well, hold on. I'm going to redo this just a little bit. I'm going to rewrite this as the square root of 16 times the square root of 12. So this is 4 rad 12, which we can simplify further. So that's 8 rad 3. Okay, so if there are no questions on Pythagorean theorem, then we're pretty much done. the proofs are going to be the same, which I feel like most people were getting by the end of class. So that should be all right. Um, but if there's any questions, anything on this practice test, go ahead and ask. I'll leave this open for the next like 5 to 10 minutes, and I'll kind of just check chat as regularly as I can and answer as many questions as I can. I'll give like a 2 minute warning. Um, Again, if you have any questions, please ask. If not, I'll be around tomorrow morning as well. Okay. Sorry that this was so late. But again, this will be up shortly after I pause this or I end it. And then I will be around tomorrow morning to to answer questions as well. This is also like not my written out work, but the actual answer key is in on campus under topics. Uh, so if you want to like try to get to that answer on your own without having all this work around you, that is available to you. And it's been available. So I would suggest at least trying to do a couple of these problems without an answer and without work and just trying it on your own. Um, but yeah, that's all I've got. And again, I'll be available tomorrow morning.